This lesson is on graphing a quadratic function in intercept form. So far, we have seen the vertex form, which is y equals a times quantity x minus h quantity squared plus k. Pulling out the vertex is what is easy to find in vertex form. Hence, we call that vertex form because we can find the vertex pretty easily. This form of a quadratic is called intercept form. We have y equals a times the quantity x minus p times the quantity x minus q. Intercept form is because we can find easily the zeros where the graph crosses the x-axis on this particular, or in this particular form that we see. And so finding the zeros, we will have x equals opposite of p and x equals the opposite of q, whatever that might be. And so we could have p and we could have q. That is where, and actually they would be a comma 0 right there, and that would be where the parabola would be crossing the x-axis, the points, and that's why we call them zeros. That is why it's called intercept form, because it intercepts the x-axis in those two spots. To find the vertex is not quite as easy as we saw in vertex form, but it's not too difficult. To find the vertex, you first find x. You find x by taking the opposite of p plus the opposite of q, the zeros, and you divide all that by 2. And then whatever you find for x, you plug that back into your equation to find y. And I'm just going to say, for lack of better words, y is x plugged back into the equation. And then I get my vertex of x and y. All right, let's put that into practice. Let's look at our first example here. We have y equals the quantity x plus 2 times the quantity x minus 2. The zeros then would be taking the opposite of 2. So I have a negative 2. And in this particular case, the opposite of negative 2 is going to be a positive 2. So I actually end up with the same zeros as what it looks like originally started. That is not always the case. So then I'm going to take my zeros, and the first thing I'm going to do is find my x value for my vertex. So I'm going to take negative 2 plus 2. I'm taking those two values right there and dividing by 2. I can easily do that in my head. Negative 2 plus 2 is 0. 0 divided by 2 is 0. Anything divided by 0 is 0. So I know my x value is 0. And so then I plug 0 back in to find my y. And I'll just write that out so that you can see how that's done. So I'll have 0 plus 2 times 0 minus 2. 0 plus 2 is 2. And 2 times negative 2 is negative 2, so that leads me to a negative 4. So my vertex then is 0, negative 4. 0, 1, 2, 3, 4 is my vertex. I notice that my A is positive. There's no negative there, so I know this graph will open up. And then utilizing the trick that we had learned from vertex form, by odd numbers 1, 3, 5, 7, 9, ... That's the difference between my perfect squares. I know that from the vertex, I can go up 1 and over 1. That takes care of that one. Then I go up 3 and over 1, and that takes care of that one. Next one, up 5, 1, 2, 3, 4, 5, and over 1. I don't think we got this many points on the other one. And then because this is a quadratic, and because a quadratic parabola is symmetrical to the x-axis, I can then take the point here to the right and then just transcribe it over onto the other side. And remember, we draw a quadratic, a parabola with soft curves, no straight lines. And we end it with arrows at the top representing that it continues on to infinity. Our next one, we see that our A is negative, so I'm just going to say it's going to open down just so I can double check that with my graph. I have a 0 at -1 because I take the opposite, and a 0 at -3. To find the vertex, I first find x, and I do that by taking my zeros and adding them together and dividing by 2. Basically, I'm finding the average. I'm finding the midpoint between the 2 points. So I could even have counted in from here. I can just take my fingers, move in 1, and then what's left is my 0. And then I would still have to plug that 0 back in order to find my y value. So -1 plus -3 is -4, divided by 2 is -2. So I know my x value for the vertex is -2. I plug that -2 back into my original equation, and I get -2 plus 1 times the quantity, -2 plus 3. Leaving my -1 out for right now because order of operations tells me to work within the parentheses first. So I get -1 times +1. I almost wrote negative there. So a negative times a negative is a positive, times a positive is a positive. So that leaves me with a +1. So -2, +1 is my vertex. 1, 2, and up 1. And then again, utilizing the odds rule that we had for the perfect squares, but understanding that whatever that is, I multiply by the a out in front. So 1 times -1, this 1 times this -1, I'm going to go down 1 and then over 1. Then I'm going to go down 3 because it's negative. 1, 2, 3, and over 1. Down 5. Let's see if that fits. 1, 2, 3, 4. Oh, we'll make it 5 and over 1. And then I reflect that over to the other side, and I get a nice parabola with nice gentle curves. Hopefully yours looks a little nicer than mine. And that is how we graph with intercept form.